Hello everyone, welcome to these lectures. So in these lectures, I want to introduce what is probability and statistics. So first, probability and statistics is always combined with each other. In some universities, they even combine these two topics into one class. And why we can do this? The reason is this probability and statistics are both tell us how to handle the randomness. So that's why in many engineering majors, we combine these two topics in one lecture. So here, before we discuss some definition of the probability and statistics, let me introduce some terminology of these topics. The first one is what is experiment. So what is experiment? Experiment is anything that can produce some data. So this is the definition of the experiment in the probability and statistics. So let me give you some example. First one, like if we look at there is a student center or before the registrar's office, so there may be a line before it. So we can treat this one as one experiment. And also, like if you're interested in the population of Canada, then we can use like a population controls or surveys as another experiment. And also, if we interested in some information about an earthquake, so we can treat the earthquake sensing as an experiment. And the last one is if, like one example from finance, like for example, the Apple stock, then if we check the daily open price of the stock, then this is also one experiment. And then this is the definition and example of experiments. And we also interest like what is models, because this is a course of math, or in other words, probability and statistics, right? So we always interested in models. Then what is the definition of models? For this one, this is actually have different definition when we talk about different situations. So there are two main types of the models. One is more theoretic, the other one is less theoretic. So for example, the first one is a mechanistic models. So in fact, this one is a more theoretic model, or say theoretic principles. And another one is an empirical model. So compared with the theoretical one, this is more about the data. So this model is also talk about the relationship between the factors. For example, if one factor is the population of Canada, another factor is how many people earned in this country. This we can, if we construct a model based on the data we have in these two factors, we can create an empirical model about these two factors. However, we know this is really depends on the observed data. So for example, if we make some errors when we record the data, of course the model will change. And there is also some other noise. So for this one, if we want to make a model become better, then we should pay attention about how we collect the data, and is there some noise, or in other words, residual variation. And also something about special case. So this means the chance if it's play a role in the model, then is this model become better or worse? So here I give 3 examples about the noise and chance. For example, there is some electric noise, some environment conditions. So this is happen a lot if this experiment is some data generated by some like physics experiment or the chemical experiment. And also there is many things about the human errors. So human errors is maybe we just record the data as a wrong number, or it's something like if we have two people to record or measure some, for example, the length of something or the weight of something. This is always like if it's between like 1 gram or 2 gram, some people they will record a different number like 1.1 or 1.2. So when this is small, maybe for our model this is not big problem. However, if we require very accurate data, this maybe will bring some problem. So when we create some empirical model, we should pay attention about this type of noise. And so this is about two important terminology in probability and statistics. So now we should give the definition of what is probability and what is statistics. So we already said probability and statistics are both tell us how to handle the randomness. However, the difference is probabilities is more focused on the mathematical, or in other words theoretical part of the random phenomena. And this is also the reason why in our lectures we generally first introduce the probabilities. We first talk about the math part, the more theoretics about this, how to handle randomness. And compare with probabilities, statistics is more about the data or about the sample. So in detail, it's a science of collecting, describing, analyzing, and inferring the information based on some numerical data. And we want to get the information about the whole population from a smaller, generally representative sample. So this is about statistics. You can also think this is a little more applied science. So that's why in some country or some university, they think probabilities is a branch of the applied math. However, statistics is just statistics. They even can be in two different departments. So this is about some terminology and definition of the probability and statistics. In our next lectures, I will start talk about the probability theories. So please subscribe this channel and see you in next lecture.